Good morning, students. Let us continue with chapter 2 polynomials. Today, first of all, we discuss zeros of a polynomial. For this, let us consider a polynomial px equals to x square minus 5x plus 6. Here, if we replace x by minus 1 everywhere in px, we get p minus 1 equals to minus 1 whole square minus 5 into minus 1 plus 6. That becomes p minus 1 equals to 12. So we can say that the value of px at x equals to minus 1 is 12. Similarly, if we want to find out p0, means value of px at x equals to 0, that becomes equals to 6. Now if we find px at x equals to 2, then p2 equals to 2 square minus 5 into 2 plus 6, that becomes 10 minus 10 equals to 0. As p2 equals to 0, we can say that 2 is a 0 of the polynomial px equals to x square minus 5x plus c. Similarly, we can check that 3 is also a 0 of px, which is equals to x square minus 5x plus 6. Students, try it yourself. In general, we can say that a 0 of a polynomial px is a number c such that pc equals to 0. Now we can easily observe that 0 of the polynomials like x minus 1, that is obtained by equating x minus 1 with 0, that becomes equals to x minus 1 equals to 0, which gives us x equals to 1 after transferring minus 1 from left hand side to right hand side. Second, if we want to find out 0 of another polynomial 2x plus 3, first of all we equate this 2x plus 3 equals to 0, that becomes 2x plus 3 equals to 0, which gives us x equals to minus 3 by 2. It is important to note that 0 of the polynomials is also called the root of the corresponding equations. Now consider the constant polynomial 6. It can be expressed as 6x raised to the power 0. It has no 0 because replacing x by any number in 6x raised to the power 0 still gives us 6. In fact, a non-zero constant polynomial has no 0. Dear students, one interesting question arises here about the zeros of the zero polynomial. A zero polynomial can be expressed as 0x raised to the power 0. Now, if we replace x by any number in 0x raised to the power 0, it always gives us 0. Therefore, we can say that every real number is a 0 of the zero polynomial. Now, if px equals to ax plus b, where a is not equals to 0, is a linear polynomial, then we can also find its zeros by the earlier said method. Equating this px, which is equals to ax plus b with 0, we get px equals to 0, means ax plus b equals to 0. Here ax becomes equals to minus b and x becomes equals to minus b upon a. So minus b upon a is the only 0 of px equals to ax plus b, or we can say that a linear polynomial has one and only one 0. Now we come to our next topic, remainder theorem. Dear students, remainder theorem is basically used to find the remainder when one polynomial, say px, is divided by another polynomial, say gx, where the degree of px is greater or equals to degree of gx and gx is not equals to 0 without doing actual division. Let us try to understand remainder theorem with the help of one example. Here we have an example. Find the remainder when the polynomial px, which is equals to x minus 5x square plus 6, is divided by the polynomial gx, which is equals to 1 plus x. For this, step 1, students, first of all we write the dividend px, which is equals to x minus 5x square plus 6, and the divisor gx, which is equals to 1 plus x, in the standard form. Standard form means, students, arranging the terms in descending order of their degrees. So Here, after arranging, the dividend becomes equals to px equals to minus 5x square plus x plus 6, and divisor becomes equals to x plus 1. First of all, we try to find the remainder using long division method. After dividing minus 5x square plus x plus 6 by x plus 1, we get the remainder 0. Now let us try to find the remainder using remainder theorem. In this method, first we equate the divisor gx, which is equals to x plus 1, with 0 and find the value of variable x. Here gx equals to x plus 1, that becomes equals to 0, and it gives us x equals to minus 1. Now put x equals to minus 1 in the dividend px, which is equals to minus 5x square plus x plus 6, to get the remainder. Here px equals to minus 5x square plus x plus 6. Therefore p minus 1 becomes equals to minus 5 into minus 1 whole square plus minus 1 plus 6, and that gives us minus 6 plus 6 equals to 0. So dear students, in this way we can find the remainder using remainder theorem without doing actual division. Now we come to our today's last concept, factor theorem. Here, if px is a polynomial of degree n greater or equals to 1 and a is any real number, then x minus a is a factor of px if pa equals to 0. It means when px is divided by gx and the remainder is 0, means px is exactly divisible by gx, then gx is a factor of px, or we can say that px is a multiple of gx. That's all about today, students. Now with the help of this zeros of polynomial, remainder theorem and factor theorem, you can try this worksheet 2, which consists of 7 questions, and come forward with your problems. Thank you and have a nice day.